This video series is all going to be about naming compounds and writing compound formulas. So when naming compounds and writing formulas, the most important thing that you can do is distinguish between what type of compound you have. So here we're going to talk about three different types of compounds. We have ionic compounds, we have covalent compounds, are also called molecular compounds, and we have acids. So all three are going to go over different type of naming rules and different rules when writing the formulas for the compounds as well. First type of compound we're going to talk about is an ionic compound. An ionic compound is made up of a metal and a nonmetal. Now, this can also be expressed as a cation, which would be your metal, and an anion, which would be your nonmetal. So here, our cation is sodium, and our anion is chlorine. Now, the rules for naming an ionic compound are quite simple. Name your cation, name your anion, or name your metal, and then name your nonmetal with an IDE suffix. So here, our cation is sodium, so we're going to name our cation sodium. And our anion, or nonmetal with the IDE ending, is chloride. Notice chlorine, I just dropped the INE ending and replaced it with the IDE suffix. When writing an ionic compound formula, I have to identify the symbols for each element as well as the oxidation states of each element. So here I have strontium, and strontium's in group 2, so it has a +2 oxidation state. Oxide is in group 6, and it has a -2 oxidation state. So what you have to know about all compounds is a compound will always be neutral in charge. If it wasn't a neutral in charge, if it didn't have a neutral charge, it would be an ion. So because I have +2 and -2 as my oxidation states, I only need one of each strontium and one of each oxide for all my oxidation states to cancel out. So my final compound formula would be SrO. Again, when writing formulas for ionic compounds, I have to identify the symbol. So for calcium, I have Ca. The oxidation state, calcium's in group 2, so it has a +2 oxidation state. Iodide is in group 7, and therefore has a -1 oxidation state. Now, notice, if I just combine one of each of these ions with a +2 and a -1 oxidation state, then the total charge of my compound is not going to be 0. It's not going to be neutral. So, instead, if I have one calcium, I'm going to need 2 iodides, indicated by a subscript 2, to cancel out with my +2 oxidation state. So here, each iodide has a -1 oxidation state. My calcium has a +2, and this +2 cancels out with the two -1s.